Hi friends, let's solve every differential equation of the form y prime equals a of t times y. First remember this is really like the following, dy dt is equal to a of t y. So you have y on one side, then you have a of t next to it. So what you can do is you can separate the variables. So in other words, you would have something like this as a first step. For example, dy is equal to a of t y and then dt. And then take the y and just move it to the left side. So you'll have dy over y, by division that is. It cancels with the one on the right side. So you have a of t dt. Okay, now we're going to anti-differentiate to get rid of the differentials. So you're going to say the antiderivative of dy y is equal to the antiderivative there. Let's try that again, of a of t dt. Okay. Now to differentiate the left side, because it's like y to the first in the denominator there, you need to use ln. So you're going to ln of the absolute value of y is equal to, now what's on the right side? Well, we don't know what of t is. It could be some function like sine of t, cosine of t, whatever. So all you can do is just keep it symbolic and say a of t dt plus c. And on the left side, we're taking the absolute value of y. What's opposite to taking ln? In other words, the natural log of something. You do that by exponentiation. So you're going to do e raised to the ln of the absolute value of y is equal to e to the, let's see, antiderivative there of a of t dt plus c this way. So that's progress. Now e and ln are inverse functions. Why is that important? Because that means you can cancel them off. Whatever the first one does, the second one basically reverses. So take this and cancel with this, which means all that remains is the absolute value of y. Now on the right side, go back a step. You have to break this up a little bit by a basic rule. So here's a basic rule of exponents. Like if you have a to the x, a to the b, then it's equivalent to a to the, say, x plus b. These rules are bidirectional. So in other words, what I mean is you can either go left to right, if I can get that to show, or if needed, you can go right to left. It makes no difference. You do it both ways. Okay, so why is that important here? That's important because that means we get to break up e raised to that antiderivative of this unknown function a of t dt, and that becomes e raised to the c. E to the c is just a constant. If you find c directly, then e to the c is just a constant. In other words, what we have is the absolute value of y equals e raised to the c, and then e raised to the antiderivative of a of t dt this way. Okay, so now what happens next? So you have to either deal with plus or minus, or just remember that the following is true. We'll call e to the c a, and let's say a can be positive, a can be negative, whatever, it doesn't matter. So then next I can say y is equal to, notice no more bars around y, and then I will have here e raised to the c, which is now called a, so replace it, and then e raised to the antiderivative of a of t dt. And then this is the solution to your equation, whatever it happens to be in a particular example. This is how you find the solution. So like, imagine y prime is equal to, let's see, what do you want to call it? Sine of t, y. So in this context, our a of t is our sine of t, that kind of situation, you see? So just plug into the formula, you're going to have y is equal to a, and then e raised to the antiderivative of sine of t dt. And then you just work through this. So it's going to be a, e raised, okay, and then anti-differentiate. So it's going to be negative cosine t, and that's the solution. Now notice that, of course, here you have a as your parameter. It's a single parameter. So if you change its values, you're going to get different curves. Like if a is 1, you would have 1 e raised to the negative cosine t. Okay, so the curve kind of looks like this. You see, that's 1. Maybe its value is negative 3 or something like that, okay? So you're going to have e raised to the negative cosine t, okay? So then the solution kind of looks like the graph there below, going this way, okay? Let me scrunch this down a little bit more. There you go. So the solution then is that green-shaped graph. So each choice of A in this particular case gives you a separate solution. Leave a like if it's been helpful.